This is the fifth and the last entry on a series of discussion videos uh, about concavity and the second derivative test. So let us answer the third exercise problem. Given the graph of the derivative of f and assuming that f is continuous everywhere, find the intervals where f is concave up, concave down, and the x coordinates of the points of inflection of f. So this is the graph of f prime of x. So to find the possible points of inflection of f prime of, no, we want to find the possible points of inflection of f. So we should look for x such that f double prime of x is equal to 0, or f double prime of x is undefined or does not exist. Okay. However, we can easily find them by looking at the graph of f prime of x. F double prime of x are the slopes of the tangent lines of this graph. Okay, so as we can see, the tangent line of f prime of x at x equals -2 is a horizontal line. Okay, so the slope of a horizontal line is 0. Therefore, f double prime of x at x equals -2 is 0. Okay, so therefore we have found that x equals -2 is a possible point of inflection. Now let us look at x equals 0. There is a sharp turn in x equals 0. So as we can see, the tangent line is undefined. We don't really know what the tangent line is at this point. Therefore, f double prime of 0 does not exist. Therefore, it's one of the possible points of inflection. Obviously, the first derivative does not exist at x equals 2 because there's a vertical asymptote in there. So if f prime of 2 does not exist, then obviously f double prime of 2 does not exist as well. Therefore, we also have a possible point of inflection at x equals 2. And similar to x equals 0, there is a sharp turn in x equals 3. Okay? Therefore, the derivative at this point does not exist. Therefore, f double prime of 3 does not exist. And therefore, at x equals 3, we have another possible point of inflection. To see if these points are actually actual points of inflections, then we should construct a table of signs. So at x equals -2, 0, 2, and 3. Therefore, double prime of x undefined in 0, in 2, and in 3. Okay. So when x is less than 0, when x is less than -2, the tangent lines look like this. Okay. the tangent lines have negative slopes. Therefore, f double prime of x is negative when x is less than 2. Okay, when x is less than 2, I mean when x is greater than negative 2 but less than 0, the tangent lines have positive slopes. Okay, so therefore, f double prime of x is positive in this interval. When x is in this interval, x greater than 0 but less than 2, the slopes of the tangent lines are negative. And so f double prime of x is negative in this interval when x is greater than 2 but less than 3. Okay? So the slopes of the slope, the tangent lines have positive slopes. Therefore, f double prime of x is positive in this interval. And when x is greater than 3, f prime of x is a line that points downwards. Therefore, the slope f double prime of x is always negative when x is greater than 3. Therefore, as we can see, as x passes through these points, f double prime of x will always change signs. Therefore, x equals negative 2, 0, 2, and 3 are all points of inflections. Also, f of x or f is concave up on which intervals. So as we can see from the table of signs, f is concave up on the interval negative 2 to 0 and 2 to 3. On the other hand, f is concave down on negative infinity to negative 2, 0 to 2, and 3 to positive infinity. Okay, that should be all.